This is problem number 1 on the sample test problems for test number 1. Use the information given to answer each of the following questions. A. The smoking rate among 10th graders was 12.1% in 2005, but jumped 45% in 2006. What percentage of 10th graders smoked in 2006? So I think it's important to not get confused by the percentages in this problem. This starting amount, that 12.1, you can think of it as like $12.1, say. And then it jumped by 45%. So the first thing we need to do is find 45% of that number. So we want 45% of 12.1. And we know that to do that, we need to convert that 45% into a decimal. And then generally of means times. And then we multiply that by 12.1. So we'll do this on the calculator. We're looking for 0.45 times 12.1. So we get 5.445. That right there is the amount of the jump. So if we started at 12.1 and we jumped by 5.445, then to find the final number, we need to add these together. So the final answer is 17.445% of 10th graders were smoking in 2006. So one correction, many thanks to Jason for pointing out my error here, but in that last line where I said the answer was 12 plus 5.445, it should have been 12.1. It's this 12.1 right here. I accidentally wrote 12, and so then when we add it up, we shouldn't get 17.445, but rather should be 17.545. Thank you again to Jason. Part B. In the stock market crash of October 19, 1987, the Dow Jones Industrial Average fell 22.6% to 1738.42 points. What, approximately, was the value of the Dow Jones before the crash? It is very tempting to try to take 22.6% of the 1738.42, and then maybe whatever you get, add it to 1738.42. Unfortunately, that is wrong. You're trying to take 22.6% of the original value of the Dow Jones, the starting value, and you know that you took 22.6% of some unknown thing, and then you subtracted it from the unknown thing, and you ended up with 1738. So this is the difficult kind of question. We had some of these in class. But here what we need to do is think about if you start with 100% of something, then you lose 22.6% of it, which is what happened in this case, then how much do you end up with? And the answer here is 77.4%. So instead of thinking of this as a fall 22.6%, I'm going to think of it as a still had 77.4% of the original. So what that means in terms of an equation is 77.4% of the original value of the stock market was supposed to equal what we ended up with at the end of the day, which was 1,738.42 points. 77.4% of the original. And you end up with 1,738 points. So we can change this to a decimal, 0.774. We can change this original to an x, of means times, and that's supposed to equal 1,738. Which means that x, we need to divide both sides. 1738.42 divided by 0.774. So we'll do that division over here. And we end up with about 2246. So that many points is roughly what the stock market was worth before the crash on that day. So how are you supposed to know the difference between a question like Part A, which was pretty straightforward, and a question like Part B, where you had to do this funny subtract from 100% thing? The difference between these two problems involves what you know. In Part A, you know the starting number. The starting number was this 12.1%. That's the start. You're trying to find the end in 2006. That's the straightforward kind of question, going from the start to the end. Here's the tougher question. You know the end was 1738, and you're trying to find the start. So anytime you have that kind of a problem where you know what you ended up with, but you want to know what you started with, that's where you have to do this funny 100% business. Let's take a look at Part C. In 1998, the total energy consumption of the United States was roughly that big number of BTUs, British thermal units. Rewrite this number in scientific notation, then give an estimate of the number of BTUs used per person. Okay, so that number in scientific notation, remember scientific notation means you have to have one number to the left of the decimal place, so 9.427, and then we're not going to write all the trailing zeros, but we do need to figure out what power of 10 is appropriate. The job is to figure out how many spots that decimal point needs to move. It's currently at the far right, and it needs to get over here so that it looks like 9.4. So counting in groups of 3 first, 3, 6, 9, 12, 15, and then one more spot to slide in there, 16 is the right power. So that's the scientific notation version of that number. And then we want an estimate of the number of BTUs used per person. So if we know the total number of BTUs used by everybody, and there are 300 million people, then I think the right thing to do here is divide. So we'll say BTUs per person is equal to this 9.427 times 10 to the 16, divided by the number of people, 300 million. Now we're going to type this into the calculator, but you can do it however you want. I'm going to get a little more practice by writing the number on the bottom in scientific notation. 300 million is 3 times 10 to the, and if you imagine writing 300 million out, currently the decimal point is at the far right. It needs to get in there to the 3, which is where it is in the scientific notation version. And I think you'll see that you need to move over 3, 6, 7, 8 places. So this should be 3 times 10 to the 8th. And then we can type this on the calculator. So I've got 9.427 times, and then there's this 10 to the 16. So I think on this calculator, I'm going to do it in a funny order. I type in my 16, then I hit this 10 to the X button right above the mouse. And 9.427 times 10 to the 16 should be the big number that we saw at the start of the problem. And then we're supposed to divide by 3 times 10 to the 8th. So I do 3 times, and this is kind of funny, 10 to the 8th. Oh, I realize I've made a mistake. Let me try this again. 9.427 times 10 to the 16, there, divide by, now I need parentheses around the bottom, open parentheses, 3 times, and then to do 10 to the 8th, you have to hit the 8 first, and then you hit the 10 to the button. Close my parentheses, that's my 3 times 10 to the 8th. I still need to hit equals one last time to get my final answer, which is that. So we've got, how many 3's here? 5 3's. So So this is roughly equal to 314233333. Let's make sure we copy that right. I think that's okay. It says give an estimate. Here's our estimate. I have a hard time looking at this number without commas, so we'll put commas every 3, and it looks like about 314 million. It doesn't specify, what you should round to. I'll be really clear on the test where you should round your final answer. Okay, so about 314 million BTUs used per person per year here in the US. And we'll show that calculation on the graphing calculator. You don't need to have this calculator, but in case you do, I want to make sure you can use it. So again, we're typing in this thing here in the purple, that 9.427 times 10 to the 16. And now as I look at it, I realize I forgot the 10. Let's sneak that in there, times 10 to the 16. Okay, so let's type that thing in on the graphing calculator. A little bit different than before, 9.427, and then times 10 to the, it's real easy. You hit the yellow button, and then you hit the button that has a comma on it. And that's how we get the E. The E is that guy right up there. 9.427 E16. That's it, divided by. And it turns out we don't even need parentheses here, although it's okay to use them. 3E8. So it's a whole lot easier to type it in on this calculator if you know what you're doing. And we should see it's the same number we had before.